All right, so this week is going to be all about SQL, better known as SQL. So does anyone want to take a shot and explain what is SQL? Structured Query Language. That's what it stands for, yeah. But what do we use it for?
Ask questions of databases.
Ask questions of databases. I also heard the word relational database. And I think, Jonathan, what did you say?
I just said it was a database.
Yeah, it's a database. So SQL is close. So SQL is not a database per se. It is what's called a relational database management system. There we go. So one of these RDBMs consists of two halves. First half is the storage mechanism, tables, columns, and rows, and the second half is the query mechanism, which is structured query language, or SQL. So this is all about making sure that our code, the things that we create via code, can persist. What do I mean? When I say persist, what am I talking about? What do I mean?
Stays.
It stays. Okay, stays. Elaborate on that.
Like the data just doesn't disappear, you can retrieve it.
Exactly. The data doesn't just disappear. It can be retrieved again. Up until now, all of the code that we've been making has been temporary. As soon as the program is done functioning, it's over. All the information you saved is gone. It all gets garbage collected. All the variables are disappeared. And which is fine for what we've been doing, but generally speaking, you're going to be wanting to make something that can actually just keep going. And one of the most common ways to do that is by setting up a database. And a lot of those databases use SQL as their query mechanism. So SQL, an SQL database, consists of a few parts. So this is a table. This is a table for students. Right here. So this whole thing is the table. Each of these is called a column. And each of these is a row. So tables, columns, and rows. That's going to be our life for the next week or so. So what is a table can represent a lot of things. In this case, it's representing students. But what's another thing you can use to represent a table? Like, what other things could you represent with a table? Spitballing here.
Budget transactions.
Budget transactions. That's a good one. What else?
Standings for sports teams.
Yeah, sports teams, sports stats. Yeah.
Inventory.
Population statistics, inventory. Yeah, literally anything. Anything can be represented by SQL tables, with the columns representing kind of the general attributes of those things, and each row representing an instance of that thing. Yes, Pavel.
Are the tables always two-dimensional, or can they be 3- or 4-dimensional tables, or more than 2 dimensions?
So when you say 3-dimensional, what do you mean?
Like you have tables which are columns and rows, X, Y axis. Could you have a Z axis as well, so that it's like a matrix instead of a table?
That's an interesting question. Not that I know of. But so what Pavel was asking is, would it be possible to have a table that consisted of an x-axis, a y-axis, and a z-axis, making it like a matrix or a cube? And I don't know what that would look like. It's an interesting idea, but I honestly have no idea how that would be, how I could represent that. But when we're talking about SQL, we're talking about 2-dimensional tables. So tables are always identified by a name. And so these things right here are SQL queries for creating a table. So create table students, create table addresses, and any name is valid, but there's naming conventions that we typically follow. So table names are usually lowercase, and they're usually a plural noun. It's also a very good practice to include a unique integer column named ID on every table you create. So making sure that each and every instance you create has a completely unique ID. Often there are data like SQL languages or SQL software that will do that for you, but sometimes you need to do it yourself. So we have some table name examples here. So if we're storing people, you'd want to call it persons. If we're storing purchase orders, we'd call it purchase_orders. If we're storing how many likes are on a post, we'd call it likes. So yeah, generally speaking, if you can pluralize it with an S at the end, that's good. Hopefully you won't have to store anything like moose, but if it does come up, you may want to call it mooses. And then columns. Each column also has a name. Lowercase singular nouns or adjectives are a good creative naming convention. So students, first name, last name, on probation. So I'm just curious, is any of this looking familiar to things we've already done before to anybody? A bit like CSV and maybe
About the varchar 255.
yeah, so we'll talk about that.
Initializing a class.
Yeah, that's
Yeah, so it kind of lines up pretty well with if we wanted to do some object-oriented programming and create an instance of a class. Because a class also has a name, and it has attributes, and every instance it's kind of analogous to a row, so keep in mind. So also someone pointed out varchar 255. So one thing is every column always has a type which determines what type of data it can hold. So integers and booleans, varchar 255 is a fancy way of saying a string up to 255 characters long. If you want something longer than that, you would use text instead. So it's all in that. So you always specify what type of data you're saving whenever you create a column.
Do you ever use less than 255 or you always use 255?
I think you always use 255. Yeah, if it's going to be short, you use varchar 255. Usually, if it's going to be longer, you use text.
It's a byte, right? So for each bit.
Yep, 255 is a byte. That's correct.
I guess that's why.
Yeah, that number you look soon enough, you'll soon realizing that 255 and various multiples of 8 pop up everywhere in coding. One example I used to give was when I was working with kids, is that in Minecraft, all the kids know the highest height you can go to is 255. They didn't know why. Can repeat the questions? Thank you. Sorry. Thank you for reminding me. So Dan was pointing out that 255 is a byte. And I was explaining that bytes do, in fact, pop up everywhere. Was there another question I forgot to repeat earlier? I think, Kenneth, didn't you ask something?
I forget.
Oh, well, okay. Sorry, I'll make sure to do that from now on. Thank you for pointing that out, Chase. So some of the column types that you'll be typically seeing, it varies from system to system. SQL is actually used by several different management systems, including Postgres, MySQL, MS SQL, Oracle. But the most common ones you'll be seeing are integers, which you know, decimals, you should know. So you can do varchar 1 through 255. So any number between 1 and 255 you can do. Oh, right, that's the question Kevin was asking, is did it have to be 255 or could you use lower ones? And you can use lower ones. I don't know necessarily the good use case for using a lower one. But if you want to, unless you want to make absolutely sure that there's a maximum length for whatever text is being stored there. So text gets you longer strings up to 16 kilobytes. Dates give you a date with no time. Timestamps gives you a date with time. And we're going to be working with PostgreSQL mostly, but you'll be encountering other SQL systems as well in the course of your life. And also other systems that don't use SQL at all, like MongoDB and NoSQL. So your database schema. Has anyone heard that word before? Did it come up in your work over the weekend? I'm not seeing any nods or shaking heads, so Thank you. Yeah, so someone want to take a shot? What is a schema? What does that mean?
Like how you represent your data.
How you represent your data. Yes. So your schema is essentially the blueprint of your SQL database. So the tables are what's actually being stored in the database. The schema is the plan for that. So as you maintain the software, it's expected that you will create new classes, write new methods, and refactor your code. You'll do the same thing with your schema. New features often require new tables and columns, or perhaps migrating existing data to new schema. Hello. We'll be talking more about that in the details over the course of this week, but you can also modify existing columns to hold new types of data. So creating a database isn't cheap. I mean, it often requires coordination with code changes and other tools. Essentially, if your database is changed mid-production, everything else needs to change around it. So if at all possible, take your time when you design your schema. You may have heard the phrase, measure twice, cut once. With schemas, probably measure 3 times, then cut once. Because, again, the more time you spend having to write SQL queries that are going to update your schema to represent things, the more you're going to have to change all of the code that interacts with that database as well. So someone says, if you're convinced you wish you had a different schema, the time to make the change is now. Making the change will never be cheaper than today. We'll talk a bit about schema design as well. So an important part about SQL is single responsibility. So one thing I've been trying to teach you is in object-oriented programming, single responsibility is it's code that's made from small modules that do one thing extremely well. Each class has one job, each instance method has one job, making sure that all of your code does what it does well without having to be built on many, like a big chunk of code, if at all possible, is always better. So smaller is always better when it comes to software, both in database design and in coding. So in a relational database management system, large tables that store more than one record or model should be broken up into multiple tables. So right now we have another example of our student here. We've got ID, first name, last name, on predation, line 1, line 2, city, state, and zip code. Does anyone see a good place we could kind of break this table up into 2 smaller tables?
One table for address and the other one is for the name and status.
Exactly. One name for a set, one name for the student information, one table for the address. And just like in code, you don't want to repeat yourself. If you have to, repeat the same information in multiple parts, that's a problem. Design your schema to avoid that data duplication. So here we've got, again, a student's thing that keeps track of their first name, last name, and whether they're on probation, and addresses, which keeps track of student first name, last name, line 1, line 2, city, state, etc. So in this case, you see that the names are being repeated. We don't want that. That doesn't make any sense, right? So obviously that means we want to cut out the first name and last name from this address. But how do we make sure that we can link a student with their address if that isn't being saved in these 2 columns?
Keep the ID
number. Which ID number?
The 1 and 2. Repeat those.
So repeat them where?
In the second, with Tiana and Nelda, the second time.
Mm-hmm. Yeah, so say giving addresses, maybe like a student ID that refers back to the student's ID. Is that what you mean? Well, I think you're on the right track. So this is the duplication. And the downside of the duplication is, of course, if a student changes their name, we can't just change it in one place, we have to change it in 2 places. So the solution to that is this. So in this case, each student has an address ID that points to the primary ID of an address row. So, which is usually the ID column, because the ID column is always unique. Therefore, you won't get any issues of people getting pointed to the wrong one, hopefully, or something with a similar one. And so in this case, we could have given each address a student ID, or a student gives each one an address ID. It can go either way in that case. So this is, yes?
How would you normally do numbering for that? Like in this case, like we started off with, we have 1, 2, 4, and 5, but you would want to keep all the students together, right? So would you start addresses at like 1000 and 1001?
In that case, what would probably normally happen is if we're starting these in 2 separate tables, is students would start at 1 and then go up, and addresses would start at 1 and then go up.
Oh, a different file entirely.
It's a different file entirely,
Got it.
yes.
Okay.
So that way, they're stored in essentially in different namespaces, and then I could be a student with an ID of 1 and an address ID of 1, which points to the first line of the first address. So this right here is typically called a foreign key. Meaning, this is, you can think of it like a passport saying, if I need to find the student's address, I say, okay, I know the name of the student or the ID of the student. Give me the student with ID 1. Find the address ID, it's 4. Find me the address with the ID of 4, and then we have all the information here. So it may seem a little convoluted, but it's actually very, very efficient and a great way of keeping track of the relationships between things without having it all stored in one huge table. What questions do you have so far about what we've been covering?
Why is this better than having one table do everything? Because you still have to go through both tables.
Just to keep you from repeating data.
Yeah.
And only add stuff to a database that applies to that person.
Yeah. So the question was, what's the advantage of having multiple tables that relate to one another instead of having one big table that stores everything? And then Stephen, you were saying that, could you repeat what you said?
It's because you only are supposed to add stuff to the database or so you have no null values and don't repeat yourself anyway. So the main goal is not to have any null values. So if a student doesn't have an address, why would you can't put address for student because there's no address, so it prevents null values.
Yeah. So what Stephen was saying was that one thing we want to do is prevent as many columns labeled null per row as we can. So if a student doesn't have an address, for example, we don't want first name, last name, on-prodation, null, 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 null. Instead, we can just leave the address ID null. If they don't have an address, nothing gets pointed to in the database. And again, it makes your code more modular. It's easier to edit that way if you don't have to think about, okay, what's already in my schema? Okay, I need to look all there and then add this, as opposed to saying, okay, I know I have to update the address with something. Maybe I can just find the addresses table and only worry about that and not have to worry about affecting every student table there is. If only the addresses need to change, then that kind of decreases the load of worrying about having to change like every row of the huge table versus having to change every row of a smaller table. Yes.
I would guess too, at least with this particular example, that it would be beneficial, say student graduates get removed from the student table, but on say like an alumni table, it's much easier with less information that addresses still.
Yeah, so an example Daniel just used was moving a student record to an alumni record. Yeah, so that would also be a lot cheaper to do because then we could say, all right, we're maybe even deleting this row, but we aren't deleting their address information because then we can point back to it later. Good. Glad you're all thinking about this. All right, so data integrity. Good schema design use improves your data integrity. So careful use of constraints like uniqueness or not null will protect you from situations like this. So we have we have emails and passwords, one email, 2 different passwords. And if I'm logging in, I type in my email and my password. how does the system know which email to use? Right? What's the danger there?
Log into someone else's.
Yeah, you could log into somebody else's account, or somebody could prevent you from logging into your account by using the same email address you did. So you'll notice that when you when you sign up for a website, and if somebody's username or email is already in use, it'll automatically detect that and tell you, hey, we've already got this email on record, you can't use it. That's typically done through SQL, because it'll look through the database for a record that has this email and if there isn't one, then it can make a new one. But if there is one, it'll tell you you can't do that. All right, so this is kind of the thing we're all here to talk about today, SQL queries. So SQL, as coding languages go, is very different than different than Python and JavaScript. It's not really a coding language at all. It's just a way of querying, asking questions of the database. So, and this includes commands that don't necessarily query for anything, but instead do something. Like, for example, create table. So the most common queries you'll be using are select, which is retrieving rows that match a query. Insert, which is inserting new rows. Updating, so that's updating a record. And deleting a row. So select. So this is the most common one. It allows you to retrieve matching rows from the database. So take a look at this one right here, select star from students. What are we, and here's our database, which only has 2 records at the moment. What do you expect that this would return? So all of the students, what about the students? Yes. So this middle section right here, in between select and from, represents which columns we're looking for. And then this represents which table we're looking for. And kind of the wildcard operator, the star here, says, give me everything from the students table. So that would return every record, every column from every record from the students table. This one right here would say select ID, comma, first name from students, saying, okay, just give me this information. So that's the cool thing about SQL is you can get all of the information on any given record if you need it, but you can also narrow it down in all sorts of ways. So if I just want, the ID and the first name, I can do that. If you only want certain records, you'll typically use this operator, where. So in this case, they say where ID equals 2. So this says, give me the ID and first name from the student's table where that student's ID number is equal to 2. So it only gives me just one row. So the where operator is very versatile. So these are some of the most common ways you'd be using it. So where something is equal to something else. So if you know the record you're looking for has a certain quality, like where first name equals John, where the ID number equals 5, where the email equals blah, blah, blah. You could also use the bang operator =, or this notation for not equal to a value. So anything that isn't equal to something, you can use greater than, lesser than, greater than, equal to, just like in regular coding. You can also do between, so where something is between something and something else.
Does between include the 2 reference points, or does it literally mean between, so it wouldn't include the 2 reference points? Like when I say 5 to 9, is that giving me 6 through 8 or 5 through 9?
Good question. So he's asking if the between operator is inclusive or not. I don't know off the top of my head. That seems like something we could look up. So I'll do that right now. SQL between inclusive. Hello, W3 schools. So the between operator is inclusive. Begin and end values are included. Good question. There we go. There's also in, so column is present in a list of values, kind of like in Python, you could say if item is in list and like column matches a string with wildcards. So we have some examples here. So this first one right here says select all from students where first name equals Andre. So what that means is we'll get every column from the students table with students who are named Andre. There are could be a lot of students named Andre. This one right here says select all from enrollments where the grade is not equal to A. So give me all the non-A students. Select all from classes where credits between 3 and 4, so anyone with 3 and 4 credits. Select all from enrollments where grade is in A and B, so anything that gives me A or B. And then we talked about that like here, where like art percent, this percent is the wildcard operator. So it'll find anything with art and then stuff afterwards. So if you wanted something just with the word art in general, you might put a % sign on either side of the word art. And then you can also do multiple queries using that and operator. So where the name is like art and credits are greater than 3. This one? So this is an alternative way of writing not equal. So you could do bang equal sign, exclamation point equals, or these two operators like this, both will work.
Is there a preference of like what's best practice to use?
Not that I'm aware of, but I don't know, maybe. Hey, Tom. So we had a question about whether there was a preference or best practice between using this notation for not equals or just using the exclamation point equals. I never heard of any best practice about that.
I didn't actually. I only see them not.
Yeah, I've never actually seen this in the wild, but it does exist.
Saying equals is more consistent.
Yeah.
What we've been doing.
Yeah. So use whichever one you're more comfortable with. People are more likely to know what you're talking about if you're using this one. All right, inserting. So inserting is how you update your table with new rows. So you have to specify which table you're updating. So insert into students. The columns you wish to insert, so first name, last name, birth date. And then you say values, and then you'd say which values go into which one of these. So the order matters here. You have to, so if you want to update the first name, last name, and birth date, you need to keep that order consistent with the values you want to insert. Update kind of is a little more versatile, but you also have to be careful with it. So you say the word update, then the table, then you say set, and then you can say which things you're setting with the equal sign. So line 1 equals 200 Trixie, zip code equals 60010. That'll leave the rest of the columns unchanged. It'll only update these ones. And then you say which one you're updating, and you can do that by ID equals 2. Using ID is the safest way to do that because IDs are guaranteed to be unique. So you won't accidentally do everything that is in Chicago. Yes?
So insert specifically just for a completely new thing to the table, so you have to reference every single column that's in there and put value to it.
Mm-hmm.
Does
So
that work, or is this a specific?
Yeah. So he was asking if for insert, since you're creating a new row, you need to name every single column so you don't actually need to put every single column in the table, only the ones that you're inserting values into. If I just did first name with Michelle, then it would still create the row, just last name and birth date would be null.
Okay.
Unless those were specifically said to be had a constraint that said not null. So meaning that they can't be null, in which case the query would be rejected. So, but only the column names you reference will be inserted. You don't have to reference all of them if they don't apply. Just be aware that if you don't, then the column will still be updated. It'll just be updated with null. And if you aren't aware of that, that can cause problems. But sometimes, yes.
Do you have to include all the things in between, like order? Like, let's say I want to put in first name and birth date. I would have to call first name, last name, birth date to keep the birth date in the third spot, right?
No. So what he was asking was, if say you just wanted to update the first name, insert the first name and the birthday without the last name, you wouldn't have to say last name null here. You could just leave that out, because it's kind of, think of it like when we do in Python, when you assign variables to that, you do this equals this equals that, this equals that. The order doesn't matter because you're specifying what it is. So long as the thing you're updating here is in the same order down here, as long as those two match up, it's fine. You don't need to include anything you're not actually going to update or insert. Good questions, everybody. I know this is like all seems very, very strange. We'll be doing some practice with this for the next couple of days. So delete is pretty straightforward. You say delete from addresses where the ID equals 2. That'll delete the entire row and everything in it. So the important thing to keep in mind about update and delete is if you fail to include a where condition, you'll affect all rows in a table. So update address set line, if you don't include where ID equals this, everyone moves to 200 Church Street. If you delete from addresses without saying where you're going to delete that, it will delete everything. So yeah, when we talk about measure twice, cut once, this is what we're talking about. You don't want to be the person that accidentally drops everything from the database. Yeah. No. I've heard horror stories of devs that have accidentally done misread a SQL query and messed up everything. So this is why we're going to be practicing. Make sure that none of you ever mess up so badly that you cause irrevocable damage to an entire database.
Would you do like branches or some sort of equivalent when you're working on SQL and stuff like that? So you don't do something like that?
So he was asking, could you do branches or something like that when working on a database? Oh, no, you can go ahead.
You just have multiple databases, but like a production database,
Development.
development database, like in a company I have, we have 3 database production. Kibble databases are lowest level, and like a medium, and then production.
Mm-hmm. Yeah. So typically speaking, most places will have multiple databases to make sure that if something messes up one, it doesn't mess up all of them, and everything's backed up. And you also, and generally speaking, yeah, you'll be doing most work on a low-level database or a development database. Once the database is in production, people try not to mess with it if at all possible, because that affects everything again.
Company I worked at, every engineer, no engineer had access to the production database besides the CTO. And there was times it was like, hey, we need to go in and manually change this production level user, change an attribute. Right? So usually it's like, okay, well, what caused that problem? Let's fix it before we just go ahead. Yeah.
I had a friend who worked at Facebook, and people would always be asking him, like, hey, can you update some information for me? And it's like, no, he can't. Like, literally, he's just not allowed to. Okay. What other questions do you have about SQL?
So, you know how we do some operations with our code?
Mm-hmm.
Like, let's say, truncating names or converting some data into, or appending some stuff, or maybe sorting it. So I've heard a lot of times it's more efficient to do it on database level query rather than doing it in code, right? If you can.
Yeah, so he was asking was, he's heard that it's typically more efficient to, if you're changing a big thing that's affecting the database, it's more efficient to do that directly with a SQL query than it is with code. Yeah, typically it is more efficient that way, but it's also like, I don't know, it depends on the system you're working with very often. Sometimes you will just be like, open up Postgres and just type in a query. But, for example, when working with Django, Django kind of has a layer of Python in between us and the SQL. It'll be running the SQL queries for us. So, and that's true with many frameworks, backend frameworks, is that you won't typically write your own SQL. However, you will also, it's still important to know what's going on back there, and sometimes you will need to write SQL on your own to figure out what's happening.
And just from like a security perspective, people can have, like if you are writing raw SQL queries as like your post, like update, create, like in your code, people can modify that because you're probably passing that query in as a string somewhere in your code, and somebody can intercept that, manually change that SQL query, and completely wipe out your database. So that's one good thing about like an ORM and an API that prevent certain inputs and outputs.
Yeah, and actually, I just remembered something that's you may have seen. I don't know. I'll take a. This is just a fun thing.
Sanitizer.
Yeah. So XKCD. So this comic is a great example of why you need to be careful with SQL. So they named their son Robert, parentheses, semicolon, drop table students.
Little Bobby table.
There's actually a real life example of this too. Somebody had a license plate false, straight up false. Anytime that license plate ran through something, or like anytime a car ran through a toll and it didn't pay the thing, they'd snap a photo of your license plate. If they couldn't read the license plate in the column, it would say false, so it couldn't read it. Anytime that false was read, it was like automatically wrote like a ticket to the guy who actually had a license plate false. Thousands of dollars worth
Yeah, and like you look at this and actually see how it happened. Be like insert into students, first name Robert, but then this thing says, okay, that's the end of this particular query. Drop table students, and that would actually do that if you're not sanitizing. So. Yeah, SQL injection. It's one of the most common ways that companies get attacked. All right, so we're going to take a break now. So let's say come back at, might as well just come back at 10 sharp. Then we'll practice some SQL queries together. And then you'll have the rest of the day to work on the challenges.
It's a serial bar between 10 and 11.
Ooh.
Now,